Welcome to Web Handling. My name is Dave Roysum. I'm quite excited to continue a new mini-series on human factors in web handling. We start with the most important component, about which nearly all other control elements will revolve: the operator's chair. This seemingly trivial element gets a big promotion when you consider that the operator is a customer and that he or she may spend more time there than any other location. From that central location, the operator can, hopefully, see vital areas of the process as well as run most aspects of the machine. An operator in a consistent central position might indicate an operation in good and safe health. In contrast, a lead operator in the bowels of a machine usually indicate that something is not going well. It also does not improve safety to have a lead operator focused on some small detail instead of scanning the entire area for potential hazards. It is ironic that the operator is usually piloting a $1 million machine from a chair that would not sell in a garage sale and would instead be left at the curb for garbage. We can do better than giving them chairs that were replaced during the last office remodeling. In fact, office chairs are quite poor for this purpose, as we will see. The ideal chair for this purpose is comfortable, but not too comfortable. By this I mean you can sit and half stand in many comfortable but alert positions for your entire shift if you need to. However, the chair needs to swivel so that you can exit quickly in either direction if you need to tend to the machine. The chair should have small arms, or no arms at all, because arms can interfere with a quick swivel and even cause a pinch point. The frame should be sturdy and the base heavy, but not too heavy so that a person can move it by themselves. In short, this is not an office chair, but something more like a bar stool. Better yet, the ideal control seating will be a lunch counter stool. The reason for this has to do with the seat height. The lunch counter stool is not so high as to make mounting and dismounting slow as it can from bar stool heights. No less important is that the lunch counter stool is not as low as a desk chair. The problems with a low seat are twofold. First, mounting and dismounting is slower from a desk chair. Second, there is a much greater height difference of the eye between sitting and standing with a desk chair than a lunch counter stool. This simple attention to ideal seat heights will improve the design of the master control panel. This lunch counter stool will also improve the operator's visibility of the machine when in the sitting position. Improved alertness, improved control design, and improved operator visibility, all as the result of attention to a detail so seemingly small as seat height. So, where do we place this machine pilot's chair? In back of a benchboard, which is a more elaborate master control panel found on many web machines. So, where do we then place the benchboard along the length of the machine, or MD? It may be where the operator can see the most important part of the process. On a coder laminator, this might be the coder, or just upstream, or just downstream of the laminating nip, as a couple of examples. However, we might also consider the footsteps of the operator and possibly helper would need to take in a shift to tend to the various parts of the machine. The optimum possible location might be answered by motion studies. Once the MD position is determined, we must next determine the CD position. Here, the overriding concern is aisleway widths. This can vary from as little as 1 meter if the only traffic were simple walking, to more than 2 meters if people carried materials such as supply or waste to more than 3 meters, if maintenance requires rigging and forklift access. Finally, note that the benchboard need not be centered with the machine, square with the machine, or straight, such as we see with this wraparound design. In fact, in many cases, the ideal benchboard placement may be none of those. Since we have little or no ergonomic studies for web machines, we must borrow from other areas that are better studied and adapt those to our needs. Here, we will use examples from a computer desk and from a bar or restaurant, both of which are very well studied. The computer desk workstation has ideal seating, elbow bend, a keyboard height just above the lap, and finally monitor location that includes near perpendicular viewing. We will adopt this to control panels, which will have a higher seat height and additional visibility requirements. The bar and restaurant example includes the heights of the stools and counters that are comfortable for both seated and standing position. Note how this height minimizes the difference of eye positions sitting versus standing. No less important is aisleways that are wide enough to accommodate 2 people. We covered aisleways for web machines in the last slide. We will cover seat heights and visibility in the next slide. The desk chair seat height, which is too low, is around 45 to 50 centimeters. On the other hand, the bar stool, which may be too high for quick mounting and dismounting, will be closer to 70 to 75 centimeters. The lunch counter stool will have a seat height of very close to 60 centimeters. The range of eye height then is about 140 centimeters for a shorter person seated to perhaps 170 centimeters for a taller person standing. Using these heights and the aisleway spacing and the lower height of a key process, we can determine the maximum height of the ideal benchboard as far as visibility is concerned. Those geometric sightlines are shown here. However, the ideal benchboard for visibility may not be quite ideal with respect to other concerns. First, it would leave you with very little control real estate area. Also, the bottom surface is not perpendicular to the sight line, and thus you would have parallax errors. We also notice a sharp corner at the knee that in a simple construction would present. Finally, the screen is slightly far to reach, and that may matter if it were a touch screen. Still, despite all, we are close to identifying the ideal shape as a slight compromise of several independently desirable features. So, do people actually make a benchboard like this? Actually, yes. Here's a picture of the standard benchboard that Beloit Corporation used when I first started as a designer nearly 40 years ago. However, that design was not unique or new to Beloit. They did their homework and actually borrowed the idea from nuclear power plant control rooms. You will still see this basic layout today in brand new control rooms, as it is quite hard to improve on. Still, in our quest for attention to details, we must also not forget several other important features. First, until all paperwork completely disappears, you should have pull-out writing surfaces on both the left and the right side. Next, you should have a rubber pad with bevel edges for the comfort and safety of the operator. Finally, overhead lighting should be as diffuse as practical to avoid glare points on the screen and other shiny surfaces, and to avoid shadows as well. Thank you so very much for watching this module in my Plant Practical video series. Stay tuned for the next clip where we continue our attention to detail by considering the two most important I/O devices of modern controls, the keyboard and the monitor.